below the ground, it starts at the dot. But
Okay.
I'll let this play, and then there's a few changes that I add to this that I'd like to go over at the end. But yeah.
Okay.
It said, this is dimension 0, and it doesn't exist. And I was like, oh, this is not gonna go well. I knew from that moment on I was gonna fail that class. Because I was way back, I was always nearest the door, and I could see the dot. So if I could see the dot, how is it that it didn't exist? And then the teacher did something remarkable. He put a bunch of dots together, made a line, and said, this is dimension 1, and it doesn't exist either, because it still doesn't enclose volume. And then he put 4 lines together, made a plane, called it 2D, and said that's the plane that all your comic strip books lives in, and it doesn't exist. And I could see, like, the kids were crushed, they were like, what? And then he did something miraculous. This is the equivalent of the, miraculous Big Bang, He did something miraculous. He took 6 of these planes, put them together to make a cube, called it dimension 3, and said, this one exists. And I was like, huh? How did that happen? Because I don't care if you put 100 million non-existing planes together, you don't get existence, right? If the dot that doesn't exist, right, makes the line that doesn't exist, makes a plane that doesn't exist, you don't get existence. You get non-existence to the 4th. Big issue. I didn't know at the time. Turns out many other thinkers had the same problem throughout the ages. One of them, one of the most famous one, was Buckminster Fuller. Another one was my father, actually, turns out. And, they thought about it, but nobody really solved the issue. And so, why is this important? Well, this is actually the fundamental axiom that most of our physics are written on. And in the math, we write those physics with. So if we have this wrong to start with, if it's incorrect or if it's incomplete, then we're going to get an incomplete or incorrect picture at the end. And so, because people learn this very early in their education, it's usually not revisited ever by the physics community. And at the end of the day, then they have superstrings theory and Calabi-Yau spaces trying to solve equation for unification for advanced physics, and they have to add, planes of freedom one after the other to get like 248 dimensions of Calabi-Yau space, and the equations go on forever. And at the end of the day, it doesn't add up. All right? So, when I was going home from that day, I had this long bus ride to go back to my home because I kept on getting kicked out of the schools closer to my home. A physicist later on told me in a physics conference that that's how I furthered my education. Because I had all this time to think about it, right? And so I'm sitting there, I've got an hour and a half to go, and I'm thinking, man, I gotta solve this dimensional problem. This is not happening. I can't live with this. And I'm thinking, and then the bus is getting fuller and fuller, and I thought, it's getting hot, and so I closed my eyes, and in my mind's eye, I extruded myself from the bus, and I started rising up from the bus, and I saw slowly the bus becoming smaller as I rose further and further, and then I saw the city I was in becoming smaller as I rose further and further and further, and then the continent getting smaller, and then I saw the Earth getting smaller, and as I rose further, I saw the solar system getting smaller, and like looking like a dot, and then I rose further and further, and then the galaxy started to look like a dot, and I thought, oh my God, it's dots all the way up. And then I flew back into the galaxy and looked at the solar system and flew back in and went back to the Earth and found the bus I was in, and I opened my eyes and I looked at my hand and I thought, I wonder what's in there. I closed my eyes, and in my mind's eye I flew into my hand and I saw it was made out of millions and millions of dots we call cells. And then I went onto the surface of one of those dots and looked really carefully, and I got finer and finer, and eventually it opened up like it was stars of dots everywhere, billions of them that we call atoms. And then I went to one of those dots and I looked in the middle of it, and sure enough, what was there? Another dot. And I was like, oh, it's dots all the way down. And I had this epiphany, like, oh my God, maybe the universe, maybe the answer to the riddle is the exact contrary. The only thing that exists is a dot. The universe makes points of infinite division and assembles them at different scales and make everything we see. I was like looking at the people in the bus, and I could see they were made out of dots and smaller dots and smaller dots. They seemed to glow with a strange aura, and at this moment. And when you have these moments of epiphany, I'm sure many of you in this room had them. You know what you want to do next, right? You want to tell someone, right? And you all know how that goes usually. You get the look like, did you take your medication this morning? And, so I ran home when I got out of the bus, and I waited for my mom to come back from work, and when she got home, I was like, Mom, I figured out something at school today. It's so awesome. And my mom was all excited, like, oh my God, he's actually enjoying school. Like, oh, maybe he had a good exam, for the first time in his life. And I'm like, Mom, today I learned about dimension at school, and they're wrong. I just went over like a lead balloon. And it's like, Mom, I think it's the contrary, that like the only thing that exists is dots, and you're made out of dots, and a smaller one and smaller one and so on. You get infinite amount of dots, Mom. And she looked at me and she said, you know what? I just worked for 8 hours. I'm real tired. I don't feel infinite at all. And, she had made a point, pun intended. And it's like if everything is embedded into each other to infinity, is how you get boundary condition. How does things differentiate from each other? This has been a big problem. It's a chasm in our understanding. How does infinity and finite system interact? Typically, we think they don't. And that has shown up in our physics really strongly. So now we have a theory for like big stuff, Einstein field equations, that predicts continuums towards singularity, continuums towards infinity, and we have a theory for the small stuff, for the atoms and the subatomic particles we call quantum theory, and quantum theory predicts bounded linear finite states. So the two don't agree. And
all right, my apologies. I was on the phone, but that was a pretty good part to it. But I need to add a crucial thing. It's that it's actually dots and holes, and that there's multiple dimensions, but we need to identify the dimensions that exist and that everything is based off of. And that they build much larger dimensions, and each larger dimension is exponentially larger in complexion and is built off of the initial structures of the smaller dimension that it is compiled of. And through this, we get the universal languages and codes, and that there's like first there is the binary code, right? And like ones and twos, but really it's actually dots and holes. And that there's an electron energy or like a wave, and it's going on in physics it's a one-dimensional vector, right? And then that's your x-axis. And to get a second dimension, you have now y-axis, and you're building up dimensions that create larger dimensions of complexity and size that break down into smaller base ones. And this is how the fractal dimensions work in our existence, like the different geometries, fractals of mathematics and geometry. And that was what sacred geometry was sacred and used as and for. And it's how energy shapes and forms and structures and transfers throughout the inner and outer larger dimensions of the universe. And yeah, on that thoughts, I would like your thoughts on this, my friends.
A lot of dimensions and holes, man. After he said there's no dots at all, that's pretty bad to start with, isn't it?
Well, because he was comparing off of the what we're actually taught in school, which is even worse, right? And that there's actually three, because you have first the two, the dots and holes, but then you have the line between them, and it's like that's like the Holy Trinity, one of the many Holy Trinities. There's so many of them, but it's like there's also, it's like you've got, I guess, one's the positive, one's negative, and one's the neutral. And that's the other, like, three of our third dimension. And out of those...
So basically, are you telling me that there's a null zone in the center of something? Is that
100%?
Okay, so that's what we're getting to here then.
Yeah.
Because I'm getting a little lost with the lines and the holes. So, and then you get a bigger dimension, you get a bigger hole, and then, yeah.
Well, okay,
so better just to say there's a null zone.
Good call. And that actually connects to...
I mean, they wrote it all over anti-gravity papers with Carr. When you see the vortexes coming together and the two ends of the cones overlap each other, that's your null zone right there.
Yes,
now,
sir.
You want to tap the 0-point energy out of that, you got to open that up. You got to pull the energy out of that. There's nothing there until you open it.
And you have to tap it from the 90-degree intersections of the opposing dimensional vortexes.
Yeah, so tap them on and off. 1, 2, 1, 2, 1, 2, just like that. And then it starts to open the hole. So I told you in the center, it's like a plasmoid. It's pure energy. It's not AC, it's not DC, it's energy. It's something that we really don't talk a lot about, is what pure energy actually is. Well, that's it.
You are so bang on with that. And that we need to exactly discuss the difference between the three and also creating identifying the fourth that is the cold electrical current and potentially engineering a fifth, or just engineering the cold current into modern electrical systems and appliances.
It's very easy. Just break the symmetry twice. That's it. All you have to do is rectify it twice. That's as simple as it gets, and it goes right into the cap. It uses regular energy, not a negative energy, not a cold energy. It's not Bedini's energy. It is normal, everyday energy after that.
And specifically what you've brought up a few times, and that's important, and that is part of Walter Russell's all of his diagrams and dimensional geometry drawings, is the vortex and the peaks and where they intersect and tapping those points. And also,
no zone that has the energy right there. He's showing it every sign.
Right, and the right-hand rule. So all electric magnetism is based off of the right-hand rule, which is dots and holes. It's a dot in the center and a big old hole around it. And that right there is dimension number 1. And the holy trinity of dimension number 1 is you have the hole on the outside, the dot in the middle, and the line to it, right? And you got like right there, and that's like your electrical field. And then the next like exponential dimension up, holy trinity from that, is your 3 fields that are 3 holes that are 3 equal circles. That is then your magnetic field and your gravitational field, and they all exist in the same one dimension, which is a full an infinite dimension between the center dot and the whole giant circle around it, and the line that is that one dimension of flow between the two, and the field that is between it, and that all 3 of these graphitic fields, the electric field, and the magnetic field are directly proportional in all their force and interaction between those 3 pieces, dimensions. That makes sense.
Yeah, it makes sense based on what they're teaching you. Yeah.
And how they interact. Well, and then it's how you manipulate it. So,
I mean, look, the Earth doesn't work like that, but yeah, it's interesting. Like, you got to start understanding a little different. It's radiation. The field is not gravitational or whatever. It's radiation. It's the simplest form of energy on the Earth. We work on radiation. Our sky has a radiant field around it. As soon as the sun pushes against that radiant field, we get the radiation of that field pushing upon us. Okay? That's why it causes problems to the human body, because you're putting a hot radiant field right next to you. So what happened to the people that were studying Tesla coils and they didn't realize they were getting X-rayed at the same time because they ran the frequency too high? They suffered bouts of radiation damage to their body. It's the fundamental field you have to see. There's always an opposite to the field, so you'll have a positive and negative, but that's the field you need to look into. That's why I say when you get into volts and amps and they start quantifying this stuff, if you don't quantify the radiant field, you failed in a magnetic understanding, right? There is no radiant field. There is no calculation for it. That's the problem with physics. They all put it on a magnetic field. Well, what's the opposite of the magnetic field? It's the radiant field. It's the radiation. They should have learned that with the atom bomb. And instead, they just build little electrons and keep going. And they went right past what it was. You literally close that thing and you get a massive dose of radiation everywhere. That's the field. So when you say, okay, I need an electric magnetic and now I need another field and create gravity, not gravitational, it's radiant. It's literally the radiation. So we see it in our Van Allen belt. What is it doing? It's capturing radiation in a belt. It's telling you it's time dilation too, by the way. So when you go out in space, you're dilating time differently.
Radiation energy includes time within it.
Well, it's the difference between your hot energy field and your cold energy field. It's what creates the time dilation. It's what creates that plasma field. That interaction is how much you're creating the distance between the two. You're literally working on the Planck scale while working on the world scale at the same time. The field on the outside has to be built the same on the inside on the Planck scale. That's how you get time dilation. So you can also talk about the compression of those fields.
Okay, so field compression is directly tied or affected by time, right? Field compression, time dilation, or no?
The amount of energy you put from one to the next with the temperature differential between the two creates the time dilation in which direction you're going.
Oh my God, what you just said is so crucial to the three and how they interact. Yeah, okay.
There's a heavy side component in the capacitor. It's the leaky capacitor, which you have to be able to build in order to get the fields to come out in the static electricity and the radiant energy inside of a coil in order to create those fields, in order to pin that plasma field down. Time dilation is not difficult. Okay, you can do it with rotating disks. It's not something that you have to have super high frequency on. As a matter of fact, the Earth does it on low frequency. It's the understanding of the fields themselves is what you got to understand. How are they interacting? What's going on there? Why are they interacting that way? And it's not until you realize that the static electricity is your magnetic field. Your radiant field is your radiation. We now should be able to put the puzzle together. The two hitting each other at different temperatures creates a plasma. You just have to look at the Earth and the solar system around the Earth, right? Just look out there. It's cold out there. It's hot in here. There's a field in between us. It's a plasma field. It is literally like standing in your room on a cold winter's day while your house is hot and opening the window.